Well, welcome everybody. My name is Troy Raszka, Vice President of Marketing for Pure Air Control Services Incorporated, and we are about to kick off part 4 of our Creating Healthier Buildings webinar series, Engineering a Self-Healing Building. So today I have some special guests with me presenting, and that would be Dr. Rajiv Sahay, and he is the director of our Environmental Diagnostics Laboratory here at Pure Air Control Services. And we have Blake Bobosky, and he is the Vice President of Air Treatment in North America for Fellows Brands, or Aramax. Welcome, guys.
Thank you.
Thank you.
So in kicking off our webinar series, the whole thing is about healthy buildings and what it takes to make a healthy building. So today, we're going to recap some of these healthy building considerations for those of you who might not have joined us in the past 3 webinars. And then we're going to dive right into bipolar ionization, then air purification, and then we're coming full circle with our IAQ Guard monitoring system. So when we think about creating a healthy building, and not just in the age of the COVID-19 pandemic, but moving forward with this heightened awareness of what goes into creating and maintaining a healthy building, you know, we look at these key areas, and we've kind of referred to it as a wheel, with the hub of the wheel being testing and monitoring or understanding your baseline indoor air quality conditions at all times, and then taking corrective action based on that data that's generated. And so at first we looked at HVAC hygiene and restoration, and then the total system hygiene or cleanliness that would include the ductwork, VAV terminals, and such. And then we looked at what it takes to actually disinfect the occupiable space, and not only the ambient space where we study and work and live, but also the spaces that we don't consider much, like those HVAC system components, ductwork, interstitial walls, things of that nature. And so today, in our 4th part, we come to air purification. Once you've done all of these things, once you understand what your baseline is, and you've made all of these corrections to ensure that your building health is optimal, then what do you do? What do you do to take it to the next level and to maintain that on an ongoing basis? And that, of course, is air purification devices, such as our Pure Plasma bipolar ionization devices and our Pure Aramax air purification devices. And once those are in place, then you have options to continually monitor these conditions through our IAQ Guard. So those are the 3 areas that we're going to really concentrate on today. So there's been a lot of talk and a lot of buzz around bipolar ionization. And I know just based in some of my own conversations with my colleagues and our customers, there's still sort of this gray area about what it is. Is it a new technology? And so that's why I felt it was important today to bring in Dr. Sahay again to help sort of give us the background on the science of plasma or bipolar ionization. So let's just get started. I mean, it's going to seem like it's physics 101 or chemistry 101, but I think it's a good place to start, Doc. So what is plasma?
Very good. That is, first of all, welcome all the participants and good afternoon. Really, it is worth understanding that what is this bipolar ionization, because still, I guess there is a lot of basic is missing so far the understanding of the whole technology is concerned. So before I go there, I have to little bit touch upon that. What is the technology behind that? To understand that, first we have to understand what is plasma. And again, like Troy said, perhaps it will take me hours and days to explain, if I go in more deep or diving down my nose there to explain everything in this short period of time is not possible. But what is possible that I can give you enough information so that you can make an informed decision. So I'm pretty sure every one of us knows the matter. Like it is even in primary grade, the students are learning that what are the state of matters. And 20, 30 years ago, you might be often seeing that solid, liquid, gas. Everybody knows that. But of course, plasma was there, but it was not that popularized, or many of you already know what it is, but I'm just recapping it. The plasma is the fourth state of a matter beside solid, liquid, and gas. So why it is important to understand that? Because our whole bipolar technology is based on the plasma technology. First of all, this plasma technology is not very new in terms of its invention. Somebody has, if you go in 18th century, you will find some references that the people were observing it, and I'm not going in deep in the detail, but if you go something 1879 or 1880, that era, people were experimenting. And I want to quote one gentleman named Sir William Crookes. He is being the first person, or get the credit, that he has observed this particular physical phenomena. Again, paucity of time, I'm not going in the detail, but like in this slide you can see that the first who has observed it is known as Irwin. So Irwin is being created because he has used the term first time plasma. So the credit goes to him. So what happened in plasma, real quickly, I want to tell you that, as you can see in the picture in the slide, that the molecules are adhered together to make some kind of matter. But when it is in the solid, then it is having the density very dense, and then subsequently it is getting less denser, meaning the molecules are getting apart from each other. In the gaseous state of matter, that the molecules are really far from each other, but still you can figure it out that it is in certain cohesion. So that's why it is giving you that certain character. Based on that, you identify that thing as a gas. But we go further, because the plasma is nothing but it is a state of matter that's similar to the gas, which is in a certain portion of the particle, they develop some kind of charge, and the charge is being developed by heating a gas that might be ionized, or maybe some kind of artificially generated electromagnetic field. So the particles start getting charged. So then the term come ion. If it is positively charged, then we call it positive ion. If it is negatively charged, it is called as negative ion. So I believe that I can just with that understanding, we can go proceed further, because I don't want to go really deep in that one. Now,
yeah, so it can exist in nature, so it's not always artificially produced. And I think that's what this slide is going to demonstrate, that even in nature this exists. Is that correct?
Yes, that is a very important slide, because I just introduced the word ion, and I guess everybody's understanding the ion is meaning some kind of charge on a molecule that makes in certain state. If it is negatively charged, obviously it is going to, by nature or by default, going to attract towards the positively charged molecule, and vice versa. So what is being observed regarding this whole background of the technology, that in the nature itself, it exists, like Troy said, and typically their concentration is going to vary from 900 to 1000 or 1200, in that kind of range. More cleaner environment you go, more better chances of getting negative ion in that area. Contrary to that, it has been observed that the positively charged ions are slightly more than the negatively charged ions, which is about, typically you can say 1000 to 1200, that kind of range in terms of per cubic centimeter. But problem here, when we have developed this forest of concrete, that's what I call, because we have created closed environment and taken control of the ventilation, meaning the natural ventilation. And that's not a bad thing, because we need to conserve energy at some point so that we can keep the maintenance cost down. But we have to pay a cost for that. There is no flow or free flow of ion in those environment and livable environment. So since it is being artificially created, often we measure very low concentration of negative ion in those livable environment. And you will surprise myself, had opportunity to measure this. Sometimes it is below detection limit, meaning you cannot have any positively or negatively charged ion. That worries me, because that is, nature has its own way to take care of the problem, and then that negative ion is being identified as one of the cleansing mechanism of nature, and that's what it is not existing. So obviously, if it is not existing, there is no cleaning, right, Troy?
No, that's correct. And I think that basically what we're showing is that with this bipolar ionization equipment, in conjunction with the ventilation system, the HVAC system, that if we can increase the quantity of these positive and negatively charged ions, oxygen ions specifically, that the air quality will be improved within the built environment. So as Dr. Sahay was alluding to a little bit earlier, the actual history of using ionization, sort of in a commercial setting, outside of maybe a scientific setting, it actually has a long history. So with the COVID-19 pandemic, everyone thinks, well, this is some new technology, when in fact it's been around, over 100 years, certainly, and used extensively in some other industries, not specifically targeting viruses. So as you can see on this slide, we just kind of take you through some of this history very briefly. And so Dr. Sahay was already referring to Sir William Crookes, who in the late 1800s, Doctor, developed this corona discharge tube, or this CDT technology. So why don't you explain a little bit about what this sort of old school plasma technology was?
Yeah, that's a really great thing, because what this gentleman did, he was doing some kind of experiment, and what he did is created a tube, and then he has electric discharge. So he saw that some unusual activity in terms of, like, the field within the tube start happening, which is having some kind of property by which he was thinking it is going to be a charged particle. So continuing to that experiment, that another gentleman named, he was a physicist from the British time, is J.J. Thomson, in 79, that what he did, he just identified that thing as a cathode rays. Cathode rays meaning it is like, charged with like positively charged ions, right? So that is the cathode rays he find. But many of you might be understanding that the electricity is nothing but it is a flow of electron. So somehow or the other, if you influence that, you can create opposite charge, and that perhaps those two gentlemen were observing, and that's the whole idea developed from there. And we have discussed several times here, customer calling and all those, that this technology, like Troy was telling, was not initially thought for the indoor air quality application, because the technology one, but we can take application depending upon your need. So very recently it is felt that we need to have something quick, something faster, something cheaper. So this technology is one of the technologies being pulled out from a food technology, because it was a proven technology in the food industry that was helping preserving the food by preventing the microbial proliferation. Because many of you understand that the food goes spoiled or bad because there is a lot of biological activity or microbiological activity happen, and then sometimes food doesn't taste good, and it has its own implication, and you think this is not a good food, so it is bad food, and you start discarding. So back on those time, people were thinking about preserving the food. So that's why this technology is being implemented, and successfully the food industry has achieved the target to making the food preparation and food storage for a little bit long. And that's where the technology was very well used. And of course in our country it was imported somewhere in 1916 and 70s, especially in the food industry, but subsequently, like Troy said, and especially during this pandemic and earlier pandemics, that people start thinking. So there is a rhetoric of references that people start trying this technology over different kind of virus particle, bacteria particle, etc. This technology, like, basically pull the hydrogen bond. Again, I'm not going in the detail, but that's how it take care of the microbes as well as other chemicals and particulates in the livable environment.
No, that's correct. And I think it's interesting to point out that ASHRAE actually recognized this and published a study in their journal about a very similar technology to what has been refined and is in use today. So again, this is nothing new. And of course, then we really started to see indoor air quality related studies come out around the time of the SARS epidemic or outbreak in 2004, and then MERS a little bit later. And we started to see the studies on the efficacy of bipolar ionization really emanate from those two outbreaks, where we had good data to reference the efficacy of these products. And it's worth noting that both SARS and MERS are very similar to coronavirus. So when we start talking about our specific equipment, and what Pure Air Control Services has evaluated and is now offering, this is the basic, type of products that we offer. It's a systemic solution, meaning that it's going to go inside of the HVAC system. So it's part of the mechanical system. And there's various types of devices that we use for various types of equipment based on the size of equipment, based on the cubic feet per minute that equipment is producing, based on location, etc. So we've sort of numbered them for you, but number one is what is called a needle point bipolar ionization bar, and these are typically found in big air handler units, and they're typically around the supply side of the coil. And they produce these ions. They're caught up in the airflow and then distributed through the ductwork in the building, which is how sort of all of these work. Then we have the smaller needle point brush units, which can go on more residential sized units. They can also be paired up if we wanted to, boost the efficacy or the output of the ions within the system. And these are very popular right now, both in residential and commercial settings. We're seeing these mounted inside of blower units so that the ions are put right in the turbulence of the blower and then distributed out. Then three, we have sort of just the needle point bipolar ionizer. And if you look, it is very similar to the bar. In fact, that's what the bar is running off of, is one of those ionizers. So they can be custom configured based on what you need to accomplish, how big your building is, the equipment, etc. And then finally, number four there, we have the tube ionizer. And it bears mentioning that this tube ionizer is very similar in principle to that original design back in the 1800s, late 1800s, where it's using a tube with the plasma charged in it to emit the plasma, whereas these needle point devices use these little brushes that you see up here and would be in an array inside of this bar to be able to produce the ions. So when we look at the operational considerations or the options for this, and we're not going to go too far into it, just about every solution is custom based on what I was just describing, but they can be wired to always be on and emitting. They can be wired with a relay to turn on and off with the air handler unit so that it only comes on when the air handler unit's in operation and blowing. And then further, they can be tied into the building automation system or your control system to allow visibility and control over their operations. So there's a lot of versatility with these products. They're scalable and they're customizable, and that's sort of the big takeaway as far as the different types of equipment that you can get into your HVAC system. And so now that we've laid the groundwork, the history, and we're looking at what those devices look like and where they go to operate. Dr. Sahay, why don't you explain sort of in more detail how these types of devices work, especially against something like coronavirus or even other things like bacteria and mold?
Sure. And that I love this slide. It is very nice illustration that what it does. Let me reiterate to our viewers that, like, you know, or the participant, that bipolar ionization is nothing but it is a process in which the decomposition of gas and other microbial or other particulates happen by adding the high energy source. Okay, when we refer high energy source, meaning the plasma molecule. So how that works, that as we have seen in the basics, that is two charged component. Like, so what happened here exactly, that in the air there is a copious amount of oxygen, to be like, you know, about 20% range, right? So those oxygen molecule become the precursor, because with the high energy that become ionized, it turns in its ion form, and that is called as like a very active molecule of oxygen, which you have seen here represented in the pink balls. So what happened, they are very highly charged radicals. There is another word used for that. And then that particular one looking for its mate, because it is highly charged, so it is trying to get some stability to make combination or partnership, and that's how the molecule is being formed. So in that case, if there is a bacteria, virus, and that kind of thing, they come in contact with this, and naturally the opposite charge develop, or sometimes they are the oxidizer. So in case of especially virus, they take the hydrogen bond away. And again, I don't want to get in the detail, because I don't want to say, like, you know, what is the hydrogen bond, then, because it is like, you know, the molecule is composed of, like, you know, protein, and there is a lot of compounds there. So I'm not going in that detail. Just consider that it is being attracted, or it is being invaded with this kind of bombarding of the nascent molecule of oxygen, and as a result of that, the depletion of the molecule happen if it is a microbial, and then denaturing it, because once it is not organized, the physiology of the organism is getting lost, and then subsequently it is going to pronounce dead. And in case of, like, you know, the other chemical molecule or non-living molecules, such as volatile organic compound, the volatile organic compounds are a very large molecules. So what these molecules is going to do, these high molecules are going to cut it in a small part and pieces of the atoms and molecules, and then again they are going to reorient, like you see in this graph, that they are going to charge and combine together to form a cluster, and the cluster is going to downfall from the main airstream, and it can be easily screen out, or it can easily filter out with the simple filtering devices, or against the gravity it is going to fail. Now this picture is telling 1,000 word itself, because as you can see in the air handler, that if the plasma is being generated, then it is going to go in the livable space, and as you can see in this box, that millions and millions of ions are set free, and then these ions are going to attract, like, you know, various molecules, meaning volatile organic compound, and like I explained you, the microbiological compound, microbiological entities, and then they are going to be having the lethal effect due to that, and obviously the filter is going to do the rest. It makes sense, Troy?
No, it does, and I think that as we, you know, zoom out to the system, and you can see how it's produced and carried through the ventilation system and into the room. Now we can zoom back in and basically have a very simplified version of what you were just talking about. It's going to take
Exactly. This is a very good, nice picture that is telling you, like, you know, molecule to molecule. Can you hover the, you know, cursor so that people can see the negative and positive charge, that what it is happening, and that negative and positively charged is kind of, you know, either destroying or neutralizing, that is the word, neutralizing that molecule or that organism. And finally, as you can see in the very last one, that the oxygen ion cause a chemical reaction with the VOC, breaking down their molecular structure, and that's how it is being eliminated from the livable environment.
So when we start to really dive into how this works and the efficacy of this technology, again, which is why you're such a fabulous guest to have on today, is you've studied this in depth right here in Environmental Diagnostics Laboratory inside of our test chamber that we have, which we'll talk about in a little bit too. But you can see here with some of this data. Now, this is an aggregate chart of various third-party labs, including EDLab, that sort of shows the overall efficacy of the pure plasma technology to these specific categories. And so the darker blue is the efficacy with the plasma technology active and being distributed through the system, and then the lighter blue is just sort of what we might call a normal state. There's no bipolar ionization going on. And so,
and it's very interesting because these like, you know, as of today, I'm doing a lot of experiment on that, and some of the data I'm going to share, and I'm pretty sure that Troy has put in the presentation some of the photo of the environmental chamber where sort of we are performing our experiment down the slide. So why don't you go on the next slide, because I'm really too excited to disclose, like, you know, my finding that what is happening. I did a very simple experiment. I have taken a bacteria called Staphylococcus aureus. Sometimes this is the causal organism for MRSA. So what is going to happen on there? Like when I aerosolize that bacteria, then I let it first settle by itself to understand the natural sedimentation rate, that how it like, you know, going to settle and how long does it take to settle. And then I have stimulated that experiment with the pure plasma and see that what is, do the pure plasma has any effect on it. And the result was phenomenal, because after, like, you know, 1 hour we start seeing that declination, whereas in the natural condition that was not the point of declination in that percentage, but at 60%, sorry, 60-minute time, we start showing the remarkable difference between that. And believe me, after, like, you know, 2 hour or 120 minutes, the bacteria is like getting lower and lower and lower, and almost, like, you know, negligible in, like, you know, 3 hours. And the 4th hour we haven't got a lot of bacteria. It was less than even 1%. So so that was, like, you know, the I'm sorry, there was a call coming. So that is one of the finding I wanted to share with you all, that, like, you know, that is really works on the bacteria. And I am settling a lot of other you know, experiment with several other organisms, but at this time I'm happy to report that it works against the, you know, the Staphylococcus aureus. Troy, can I have my next slide, please? This slide is a very, very, you know, in simple way, that a lot of customer call in here and like, you know, asking that, like, how much, you know, ion is being produced, and how much, you know, the longevity, or how long this is going to be effective, what is the time, etc. So I thought, why don't I set the experiment, and I promise you that down the presentation you will see my environmental chamber photo. But this chart is showing you that the negative ions, like, you know, from the 3 different product in terms of baseline, you can see like, you know, that it is quite amazing. It is, like, you know, reaching over 180,000 and times 10 raised to the power 3. So it is like lot of ion is being produced, and that is being useful. So far, the positive ion concentration is concerned, because nowadays there is a trend that people are trying to generate, like, you know, the negative ion more, because it is being shown in several literature that it is more effective against the microbes and the VOC and things like that. So we have taken or chose one of those ionizer, which, like, you know, more on the production of the positively charged molecule, contrary to the negative charged molecule. So you can see that 3 of them, the equipment number 2 is very smart in positive, negatively charged molecule, has produced much more in concentration than in terms of the positive ion concentration. So yeah, there is a variation in the market. So it need to be based on your need, that what you're trying to accomplish, you need to find just the right product. Can I have my next slide?
These are other products that we were evaluating in conjunction with the pure plasma technology that we have brought to market. And so you can see that there's a pretty big difference. And again, this is the comparison of ions generated in the room. once it goes out into the occupiable space. The next slide that we want to look at here is going to deal with sort of the ions or the output of ions at the device. Is that correct, Doc? I mean, it looks like you're looking at 1 foot away from the device and then 2 feet away from the device.
Exactly. And that is like, one of the very frequently asked question that like, at what point we get like most of the ions. So this graph is very clear that like, 1 foot distance from the source is superior than in terms of like 2 foot. But this is within a closed chamber, within an experimental room. I have also done some experiment, which is like, the different length. And I'm happy to report that like, some of the ionizers are even like, discharging the ions, which is kind of maintained almost in a similar concentration if it is traveling through the duct up to 30 and 25 to 30 foot from its source. And that's a very valuable contribution, because now we understand that like if it is traveling through the duct, if your duct work is having some problem, then the ion kind of going to clear it up to 15-30 feet. That what we have noticed. And as I said you earlier, that I have measured like on different on the 5 and 10 feet intervals and up to 45 foot. I have done the measurement. The experiment is still continuing, so I hope that I will be able to bring more data to see that how we are going to utilize this technology effectively.
Now, Dr. Sahay, we had a question that came in, and it absolutely lines up with this particular slide. And that is, as a result, this is from Bruce White, one of our attendees today. He asked that as a result of the ionization process, is any ozone released as a result?
Answer to that question is yes, but at the same time it is being like so beautifully managed that the production of ozone through the ions is not going to be effective, or is not going to have any harmful effect on the occupants, because as you can see in this slide, and Troy, you said this is going hand to hand, this particular slide, because as you can see, the California regulation or regulated threshold is 0.05, and the plasma technology or the plasma equipment or the different kind of product which I have tested has not produced anything more than 0.01. So it is far less, it's a negligible. But at the same time, I want to inform customer that if it is like big tubular kind of ionizer, which typically is not being used in the indoor environment, that might be having some ozone issues, but it can be also managed, because you have to be fixing the distance and things like that. So we are in like in either case we can very safely implement this technology for our purpose.
Yes, thank you, Dr. Sahay. And as promised over here, we do have a photo of your test chamber with one of the experiments set up. And I think it's worth noting that we have submitted a white paper to the Continental Automated Building Association, which they have accepted our abstract for this white paper. And so Dr. Sahay and his team at Environmental Diagnostics Laboratory is hard at work on gathering this data, and we'll be writing it up into a white paper to be reviewed and published through CABA. And so some of this data that we've shown today is just a preliminary set that just goes to show the efficacy and what goes into studying this. Is that right?
Yes, as you can see in the far left picture here, that like there is a sort of like 1 cubic foot space is there, and we are also throwing like the volatile organic compound, like various kind of particulates, and we are measuring the concentration of the plasma or the ion generated, or how much it is producing, and then their post effect, that how quick or how sooner it is going to clean the stuff we have thrown in that chamber. And that gives me kind of an idea that how it is going to be used in a real world case or real world scenario. So it is pretty cool. And the experiment, as I said you, that just after 1 hour before this presentation, guess where I was? I was measuring some of these data, and as I'm doing the presentation here, my colleagues are like, monitoring it, and that's why perhaps you see that one call was coming, meaning that some data was reported. I do apologize for that, but I do know that my colleague was trying to inform that his time and he's collecting the data.
Well, thank you, Dr. Sahay. I really appreciate it. And I think it bears mentioning that our next guest, Blake Bobosky from Fellows Brands, Aramax, we actually tested this brand of commercial air purification device in this very chamber. And in large part, it was what made us make the decision to partner with Fellows and Aramax on these pure air control services and Aramax solutions for the indoor environment. So without further ado, we have Blake Bobosky here, Vice President of Air Treatment North America from Fellows Brands. Welcome, Blake.
Thank you, Troy. I really do appreciate the time today. We will briefly just go through what our solution is. We're going to talk about our EnviroSmart technology, recently launched PureView technology, our multi-stage filtration, and then our product assortment that's available through Pure Air.
Uh-oh, what do we got going here? Looks like something is not showing. Or do we have, is this?
So
Okay.
I could talk through it. So we have a smart, effective, integrated, and reliable solution. Smart, we use commercial grade sensors. The units turn on by motion, sound, and odor. Effective, we use commercially grade filters with a pre-filter, active carbon, and a HEPA filter that's dipped in antimicrobial treatment. We too use bipolar ionization. Integrated, we have units that are available as a portable solution where you can just plug it in, or wall-mounted units where you permanently mount to the wall. And then reliable, these are commercial grade machines. We use Panasonic brushless motors. We have a 5-year warranty. These are Energy Star rated. Moving on, so our EnviroSmart technology, as I mentioned, with our traditional units, they turn on by motion, sound, and odor. And then the launch of our PureView technology, we have 2 laser sensors that's gathering information on a mass measurement of ultrafine particles, and it's viewed with a screen. We'll talk a little bit more further about that, but basically the units are continuously monitoring based on occupancy and air quality, and what the sensors are measuring. It'll turn the units onto the proper fan speed. So our technology is efficient. They're Energy Star rated, as I mentioned, and basically, if the air is clean and there's no occupancy in the room, the units will run about 3 watts. They'll shut down to a minimal amount. If it's the PureView technology, the actual screen will go into sleep mode. So this helps extend the life of the machine as well as the filters.
And I can say we have them here in our own headquarters, and they run super quiet. They're not like what you would consider an air scrubber or loud fan to be. You can hardly hear them running when they kick on and are doing their thing, which is pretty cool stuff.
Yes, and that leads us into PureView. We launched in 2018. So we took our traditional units that turn on by motion, sound, and odor, and then we added a laser sensor that's measuring the ultrafine particles as it comes into the machine, and then as it exits the machine after it's gone through the 4-stage purification system. We also have the PureView screen, which we say makes the invisible visible. So the first screen that you're seeing today, it's basically really for the end user, for students, teachers, staff, employees, that they know that there's a localized air quality solution in place. This is representing 99% of the particles are being captured. There is a VOC bar below the 99%, and that's representing in this picture that the air quality has no odor, so it's blue. It will change to yellow or amber as it starts sensing odors, and then it'll turn to red with poor odors. So this is really just reassuring teachers, students, staff, patients that their air quality is clean. The next screen here, if an HR director or somebody else would really like to look at the PM 2.5 levels, the screen is showing a 9 on the in and then a 0 on the out. What does that mean? It's a weighted mass measurement. We try to keep it very simple, where 0 to 12 is considered clean, 12.1 to 35 is fair, and 35.1 and higher is poor. I've been in a facility where that bottom number was at a measurement of 8,000, so it's terrible, poor air quality, and on the output was still 0, so all of those ultrafine particles were being captured in our 4-stage filtration. The screen is very intuitive, so it tells maintenance what filters are in the machine, as well as the life remaining of the filter. As the filter wears down over time, once it's less than 15% life remaining, it will say replace filter. Once it's less than 5%, it will actually be stuck on replace filter, notifying maintenance to change out the filters.
And what is the expected filter life under normal conditions? What would it be?
Sure, in the normal office environment setting, the HEPA filter will last on average 12 months. The active carbon filter is about 6 months, and then the pre-filter that comes with the machine, it's a visual check after 3 months, but in a school or an office setting environment should last 12 months.
Well, excellent. And I can say that this PureView technology certainly aligns with what we do at Pure Air Control Services from an indoor air quality standpoint, and having it at your fingertips right in your room is really a game changer.
Yeah, and as you mentioned too, with regards to PureView, you know, the units will get to level 4, fan speed 4. There's 5 levels of fan speeds. Or to get to the 5th level or turbo mode, the air quality has to be poor and 20 minutes of no motion or sound. So it does a turbo cleaning when people are not present. What we're showing here today with our filtration, number 1 is our fibrous filter. That's to be capturing larger particles that are in the air. As I had mentioned, it's about a 3-month visual check, but it should last in a normal environment up to 12 months. Number 2 is the active carbon filter. That's going to adsorb VOCs, gases, and odors. As I mentioned earlier, average life with that filter is about 6 months. And then number 3 is our HEPA filter. It's dipped in an antimicrobial treatment where bacteria will be captured, it will starve and die. These are all proprietary filters to us. There's a magnetic chip in the filters that is actually communicating to the machine, telling the machine what filters are in place. So there's no fake filters in the marketplace. We also do use bipolar ionization, as previously discussed by the doctor, to capture those ultrafine particles.
Yeah, that's excellent. And I think that, you know, this is really where a lot of questions will come into play is, you know, what size unit do I need for my classroom, my boardroom, a bathroom, or a medical office? And I think this slide goes a long way in explaining not only the square footage these devices are covering, but also the different air change rates. So why don't you talk to us a little bit about that?
Yeah, I appreciate that, Troy. So basically, our system is a localized solution. We say capture the risk at the source of contamination. So we have portable units as well as the wall mounting units. So, and we typically always quote for 5 air exchanges per hour. So on the left side of the screen, we have the AM3 PC or the regular AM3 units. They will handle 5 air exchanges an hour for 300 square feet or up to 3 air exchanges an hour for 550 square feet. So the stand units, like I mentioned, they just plug right in. The wall-mounted units come with a hot and neutral wire where a certified electrician will hang and install. In the middle of the screen we call them our fours. So we have the AM4 PC, which stands for PureView, and then we have the non-PureView units. So the fours will handle about 650 square feet at 5 air exchanges per hour, with 3 air exchanges an hour up to about 1,100 square feet. And then the units to the right is our AM2. It hangs on the wall just like you'd hang a picture. It comes with a mounting bracket. It plugs right into the wall as well. You can add the accessory stand unit. So it could be a portable solution, or we offer a recess kit where you can mount it inside the wall as a hard wired solution. With the recess kit, it's ADA compliant. This unit handles 150 square feet at 5 air exchanges an hour, or up to 250 square feet at 3 air exchanges per hour. All of these units are available through our partnership with Pure Air Controls.
Excellent. Well, thank you, Blake. That was very informative, and I think that the intent of this educational webinar was to sort of show that we offer both a systemic approach with having the equipment in the air conveyance system, and then we have the extra layer of assurance in your building by putting these in high traffic areas, like I said, classrooms, bathrooms, boardrooms, to be able to purify the air again throughout the entire system, and then right at the room level, providing the highest level of assurance to your staff and your occupants in your building. And so once these systems are in place, and very much like the PureView technology that's in the Aeromax units, the final piece de la resistance, right, is to be able to monitor your baseline conditions in your building after you've established what they were, what areas needed correction, and you made those corrections. Now you've installed air purification, they're working, we're checking, there's no ozone being produced. Now you're able to put these remote sensors throughout a building and be able to monitor the conditions of that building 24 hours a day, 7 days a week. And so I know we talked a little bit about this way back, maybe 6 weeks ago, when we started this whole webinar series on understanding the baseline. But I'm going to just briefly recap it here. And of course, we're always available to answer questions. But basically, there's 2 ways to manage this, and that is Pure Air Controls would come alongside. We would offer it as a turnkey solution, almost like a leasing solution, where we would install the monitors, we would set it up, and then we would set all of the parameters and monitor the conditions. If something should go beyond the threshold that we set as acceptable, then we would be notified and would in turn notify you. We would look at the trend and then make recommendations for corrective action. Of course, we can also set this up for your facility and let your facility team and engineers manage it and use it as a tool as part of your larger BAS system. Basically, these are what we call nodes. All these little sensors are placed inside these nodes. Per the well building standard, they should be placed about every 3,500 square feet. And we typically place them near the thermostats because they too, like the Aeromax units, could be plug and play into a wall outlet, or they can be hardwired into the electrical system. So they would bring a 24 volt thermostat line down, and we would step it down to 5 volts, and that's what powers them. And so they look at CO2, particulate, VOC, relative humidity and temperature. They can also be customized for ozone, formaldehyde, and carbon monoxide. And so it collects this data in real time. It can use a Wi-Fi connection, or it can use a dedicated cellular network that we set up, so it doesn't have to go in to your secure network. It can operate on its own network, and it's going to send all of this data to a dashboard. And so as you see on this picture, there's a dashboard, and you set what your conditions are as poor, moderate, or good. And if it happens to go into the moderate or poor range and stay there for any amount of time, and we can set this up in the dashboard, then either a text message or an email message would be generated to the administrator of this system, and then we could talk. We could look at bringing in a more high-level industrial hygienist type of investigation, and then determine what corrective actions need to be taken. Again, this logs data and generates reports. It's great for compliance monitoring and reporting, like for lead and for other scenarios. And you can basically customize these reports however you want to see them. You can go and select date ranges. You can just look at VOCs or particulates, or you can look at everything. You can set them to generate weekly and just end up getting emailed to you in your inbox. So it's a very powerful system to keep an eye on things once you've got that baseline optimal. And it really does, in conjunction with this air purification by Aramax and the pure plasma bipolar ionization, help to create what we like to call a self-healing building. It's constantly being purified and cleaned, and if something starts to go out of line, you're notified almost in real time. Again, I don't feel like we need to dwell on this a lot because we've talked about it through this entire series, but particulates, create a number of issues within the built environment. Coronavirus, other types of contaminants can attach themselves to these particulates. Again, CO2 is a good measure of adequate ventilation. It confirms that these new ASHRAE guidelines of dilution are working. It can also help you to identify areas where there's not so great of ventilation and make those corrections. And again, just like the Aramax and their PureView, this can also take a look and keep an eye on these VOCs. And again, with the heightened awareness and cleaning of coronavirus, we're starting to see more and more issues being reported by irritants from VOCs, from over cleaning maybe. So again, we're right up against our time. We thank everyone for hanging out. We're going to answer some questions, but again, this isn't the first time dealing with a lot of these indoor issues, like was earlier referenced, SARS, MERS. Pure Air Control Services were there for both of those as well. We've developed protocols, improved our methods since then, but we were founded in '84. We have these 3 specialized divisions that focus on every facet of the indoor environment, and all told, we have over 700 million square feet across 12,000 buildings. So all of these divisions and the personnel that work in them keep up with their certifications. In fact, Dr. Sahay's lab was the first commercial laboratory to be certified for environmental coronavirus testing with the PCR technology by A2LA. So that was a very big accreditation to come our way. So without further ado, let's get to some of these questions, and we do have a few. Hopefully we'll be able to get to all of them. We answered about ozone. We have a question from Sheila Bombao, who asked, is the ionization affected by humidity in the room or in the environment? So Dr. Sahay, I don't know if you would know the answer to that, but does humidity affect the effect
Yes.
of ionization?
Humidity has an effect on the ionization because as we were discussing earlier, that basically it is changing the state of the matter or the plasma. So if there is a humidity, then there is a denser media, so you need to exert more in order to get the ions, and vice versa. So yes, humidity can be one of the effective factor, but it's just not going to disturb because it need to be extremes.
Well, okay, that makes sense then, and I thank you for that. We had Sean Vanos. He's asked, would it make more sense for the ionizer to be placed prior to the filter media before the supply air enters the room?
Answer to that question is yes, because remember, if you put the ionizer first, then all the precipitated material is going to be screened out or filtered by the filter system, whatever filtration system you have, is going to help you to filter out all those, like, the nuisance thing which is fall down from the air stream otherwise.
Let's see here. Are there any negative effects of bipolar ionization on the human body? And that was from Don Stanek.
Don, this is an excellent question, and there are a lot of literature there. Typically, it is being suggested that the positively charged ions are going to have some adverse effect on the human, human health and hygiene kind of situation, because sometimes you feel lethargic, sometimes you have feel out of stamina, that kind of thing. But those are limited to the positively charged ion. But in case of negatively charged ion, so far the understanding of the science is concerned that it is not impacting the human life in a adversely manner or in an adverse manner, but still the research are going on that is there any effect or not. So this is an excellent question.
So you were in that case, you would have to have a lot more positively charged ions than negative ones, or is that
Exactly.
you were saying that basically it's only emitting positive ions, and if there's
Exactly.
an excess of positive ions, that's the
Yes.
effect?
The positive ion when it is in excessive, okay, because typically that kind of situation never happen that easy. But yeah, some situation, there are some papers, we can respond him. If you would like any more detail, we can supply him the source material on the experiments what is going around.
I got you. And then it says we have Ken Mays has asked that what are some of the pros and cons of needlepoint versus the tube emitter?
Ken, this is another excellent question, because during the presentation we have alluded the fact that the tube one is there is a possibility of getting ozone created. So we have to be very smartly or strategically place that to minimize the effect of ozone, because ozone in excess of 0.05 is not good. It has adverse human effect. But in the bipolar ionizers, that thing, I have shown you one of the picture that the concentration of ozone in that not that range. Second benefit is that the installation, because it doesn't require a lot of space and it runs relatively on the less power. So that is the second advantage. Third advantage is that it has a longer life, and you don't have almost worry-free, maintenance-free kind of scenario, because there is no deposition of nuisance dust, because there is no big surface area. Whereas the tube one, it has some surface area where you can have to do the housekeeping or maintenance on that. And the fourth one is that the manpower, the installation of the plasma with the bipolar ionizer are little less cumbersome than the otherwise.
Yeah, so less power. The needlepoint brushes use less power, less maintenance, typically last longer. So there's not a filament or a tube to actually replace or go bad, I think.
Sure.
Is that. And then this is a question for Blake from Mitchell Sanchez, and he is asking, what are the dimensions of the Aramax professional devices?
So depending on the unit, Mitchell, so we have the 3, like I had mentioned, or the 4. The 3 is about 20 by 20 inches by 10 inches deep, and then the 4 would be about 20 by 40 inches, about 10 inches deep, roughly. Yeah,
and like I said, we have them in our conference room. They're up near the ceiling. You hardly notice them, and they're certainly very quiet. And then let me see. Yes, okay, so Jeffrey Hunt has asked 2 questions, and then I think we'll end it with this. Thank you all for your patience. We still have a lot of folks on, so that's very encouraging. And of course, we can take questions offline. You see our contact information there. I'd be happy to put you in touch with Blake, and he'd be happy to jump on any kind of consultation call with us. But we have our 2 final questions from Jeffrey Hunt, and I'll answer the first one here, and that is, yes, we have handouts. So if you look on your dashboard for the go-to webinar meeting today, there should be a little tab that says Handouts. And so we have some product cut sheets on each of these products today, the Pure Plasma, the Aramax, and the IAQ Guard. And we also have the complete slide deck that we've presented to today in PDF form. So, and it's a pretty lightweight download. And so again, that has our contact information on it. Feel free to reach out. And then finally, almost coming full circle, Dr. Sahay, Jeffrey has asked, how do you determine the actual presence of COVID-19 in the environment?
That's an excellent question, Jeffrey Han. I'm glad that you asked the question because there are a couple of ways you can do it. The very first way is either surface or air. You got to collect the sample. So for the surface sampling is concerned, it is being handled by use of a swab. Like you swab the area of maybe 4 inches by 4 inches, select in the suspected, area in that building or wherever you are trying to do, and then the swab is good and that is being extracted, and finally we run PCR on that. That is the one way by which we can do the surface sampling. So far air is concerned, we have a sampling cassette which is called as air sampling cassette, which is equipped with a filter paper, and then you're supposed to draw the air on that filter paper, like maybe 4 to 5 liters of air per hour, and you have to do at least like 8-hour or 10-hour sample, and then that way we can also extract if any viral particle is on that sample. We can again go ahead and run the PCR to in order to give you positive or negative answer. That is the one way of doing it. The other way is that like you need to evaluate the total hygienic situation. If you have more microbial load or the load of the biota in your environment, then chances are like you are vulnerable. That is the word they're using, because the virus is not going to not going to exist solo, because it has to have a host. So if you are having the microbial load or the environmental load in the microbiology world, such as bacteria, fungi, and other organisms, then the virus are more likelihood that they are going to be existing there. That is the indirect method of doing testing, for which you have to collect a number of sample and data, and that way you can guess that whether it is possible or feasible to have COVID in that environment or not. But at this time, the PCR or RT-qPCR is the gold standard, gold technology, by which we can test the surface and air sample to figure it out that whether there is a COVID inoculum or COVID problem there, or COVID-19 virus problem is there or not. And
Right,
one more thing I want to add, that never use the word COVID, because COVID is a disease. Actual organism is COVID-19 virus, or you can say SARS-CoV-2 when you contact any laboratory or you want to do the testing for the environmental purpose.
Right, and then so as a recap, the PCR technology allows you to see sort of the genetic fingerprint of the virus, correct? So it's not like you're looking under a microscope to see it. You're actually looking for the genetic code of the virus collected from those samples.
Yes, that's a very excellent point, Kobe, Troy, because the viruses are sub-microscopic particles, meaning you won't be able to see the virus in the regular microscope. You have to have the electron microscope, and you have to have lot different protocol. But our intent is to identify that which we handle based on the gene, because gene is the unit of an organism. So if we identify the gene, then we have a confidence that this organism exists there.
Well, thank you, Dr. Sahay, and thank you, Blake, for helping me out today and being our special guests. Again, if you have any further questions, feel free to email us or put them in the survey at the end of the webinar, and we will be timely with our answers. The webinar was also recorded, so we'll be following up with all of you and sending you a link to this recording so you can view it again or share it with your colleagues. Again, on behalf of my guests, I'm Troy Raszka, Vice President of Marketing here at Pure Air Control Services, and we're always here to help you create a a healthier building. Thank you.
Thank you very much.
Thank you.